Hello friends, welcome back to my YouTube channel. So in this video we will start the new concept, new topic, that is stiffness method. So before solving the problem, we will see the what is the procedure of solving the problem by using the stiffness method. So we will see one by one. So our step number 1 is to find out the degree of kinematics. So it is denoted as dk. So we have already made the separate video on while studying the indeterminacy of structures. I have already made the one video of on this. Here I will show. Here I have already made the how to find the degree of freedom. So it is also called as the degree of freedom. So how to calculate the degree of freedom? So by using this formula for beams, by using this formula as well as manually. So I'll give the link in the description box. So before coming to the stiffness method, you can go through this video, otherwise you don't understand how to calculate the degree of freedom. So in this video I have explained in detail so how to find out by using this formula as well as manually. So when it comes to stiffness method, we have to do the manually. So if you calculate by this formula, you will get how many numbers of decays present at this particular problem, but you don't know on what point the decay is acting. So when you calculate by manually, so you will get to know on what point decay is acting. So I will give in the link in the description box. You can see that video before coming to the stiffness method. So after that, step number 2 is giving name to the coordinate of dk. So if you get the dk2 number, then give it to the 1 2. If you get the dk3, give it to the number 1 2 3. So like that we have to give the name to the coordinates. So step number 3 is to find out the stiffness coefficient. So to find out the stiffness coefficient, for example, if our unit rotation is at A, so unit rotation is applied at point A, so it always rotates the clockwise direction. So the force produced at this point is 4I divided by L, and the force carries from here to this point B is half of this. So half of this is nothing but 2I divided by L. So similarly, if we applied the unit rotation at point B, so it always it moves the clockwise. At this point, the force developed is 4I divided by L, and so force carries from this point to here is half of this. So half of this is nothing but 2I divided by L. So when we applied the unit rotation at point B, so the force developed at this point is 4I divided by L, and the force carries far end. So at far end is half of this. Half of 4I divided by L is nothing but 2I divided by L. So similarly, so if we apply the unit rotation at point C, the force at point C is 4I divided by L, and here also 4I divided by L. Here also it clockwise, here also clockwise. So from here to here carry over is half of this is nothing but 2I divided by L, and half of the force carries from C to B is half of this. Half of this is nothing but 2I divided by L. So this is how we need to find out the coefficient of the stiffness. So while solving the problem, I will explain in detail. So this is our step number 3, find outing the stiffness coefficient. So our step number 4 is to determine the stiffness matrix. So stiffness matrix is nothing but is denoted as K. So K11, and for 2 into 2 matrix it is K11, K12 and K21 and K22. For 3 into 3 matrix it is K11, K12, K13, K21, K22, K23 and K31, K32, K33 for 3 into 3 matrix. So here K11 is nothing but, here K11 means force developed at coordinate 1 due to the unit rotation applied at coordinate 1, and K21 is nothing but force developed at coordinate 2 due to the unit rotation applied at coordinate 1. So similarly here K21 is nothing but force developed at coordinate 2 due to the unit rotation applied at coordinate 1, and K22 is nothing but force developed at coordinate 2 due to the unit rotation applied at coordinate 2. So similarly this is our step number 4. So our next step is to find out the step number 5 is to find out the fixed end moment. So we have already seen the how to find the fixed end moment while doing the slope deflection method as well as in moment distribution method. We have already solved I have already told how to find the fixed end moment. So you can go through that video. And so by finding the fixed end moment we need to use this formula. So by using this formula we'll calculate the fixed end moment for this particular kind of span. So while analyzing I will tell you how to calculate the fixed end moment. Our step number 6 is to find out the P matrix. So P matrix is nothing but P is equal to P1, P2, P3. For 3 into 3 matrix, so we need to apply this formula. For 2 into 2 matrix, we need to apply this formula. So P1 is nothing but the total fixed end moment at coordinate 1, and P2 is nothing but the total fixed end moment at coordinate 2. So see here. So for example, this is the coordinate 2. This is the coordinate 2. So fixed end moment of coordinate 2 is nothing but MFCA plus MFCB. So coordinate 2 is, or P2 is nothing but, for example I am telling. So P2 is, it becomes the, I will tell you orally, P2 becomes the MFCA plus MFCB, and for P1 becomes here if when we apply the unit rotation at point A, so our P1 becomes MFAB. So while analyzing the problem I will tell in details. So this is our step number 6. So step number 7 is to find out the theta coordinates. So we need to find the theta coordinates here by using this equation. So P matrix plus K matrix into theta matrix is equal to 0, or K matrix into theta matrix is equal to, I have taken P to right side, it becomes minus phi. So substitute all the values. So K matrix is nothing but, so K matrix is nothing but this value, and theta will get in our step number 2. So we'll get theta here, we need to put that value, and P matrix is nothing but we need to put this or this according to our problem we'll put. So from this we'll get the theta coordinates, and our step number 8 is to find out the final moment by using the slope deflection equation. So we have already solved the slope deflection equation. How to find the final moment I have already explained. So by using these two formula we'll calculate the slope deflection equation. For MAB we have the formula MFAB plus 2EI divided by L, 2 into theta A plus 2 into your first point plus second point theta B minus 3 dou divided by L. So this value, if in problem deflection value is given, then only we need to substitute, otherwise we need to neglect this. So MBA is nothing but fixed end moment of BA plus 2EI divided by L. So length is the span of our BA span, we need to put here. So 2 into theta B is nothing but our first point plus, and theta A is our second point, minus 3 dou divided by L. So by using these two formula will calculate the final moment. So our step number 9 is to find out the support reactions. So we have already solved the support reactions. So while solving the slope deflection method as well as moment distribution, when they asked to draw the SFT diagram, so then we need to find the support reactions, and our step number 10 is to draw the SFD and BMD. So we need to draw the BMP diagram by using these final moments value, and SFT diagram by using the support reactions. So this is our step number 10. So when they ask to draw the SFT and BMD diagram, we need to solve the up to step 10. So when they ask to find the stiffness matrix, then we need to do up to step number 4. After find outing this stiffness matrix, we need to stop here. When they ask for find out the stiffness matrix, then we need to stop here only. So if they ask to draw the SFD and BMD, then we need to solve up to step number 10. So up to here. So this is the working procedure of stiffness matrix. So in next video we'll solve problem on this method. So I will give link in the description box. So how to calculate the decay. So I already made the separate video on this, how to find this. So before coming to this video, you will go and see that video. You will come to know how to find out the decay. So when we are doing the stiffness method, we need to calculate the decay by manually, not by using the formula. So because when you calculate by using the formula, you will get to know how many numbers of decay is present, but you don't know on which point decay is acting. So when you solve by manually, you come to know the decay is acting on what point. So that you need to know how to calculate the decay by manually. So if you see that video, in that video I have explained in detail. So before solving the problems on stiffness method, we'll go and see that video. So here this is the working procedure of the stiffness method. So I hope you all are understood. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.